Jacqueline Saylor, and I'm the project manager for the Civil Development Company. I'm currently leading a group of 5 other engineers in developing a 40-story high-rise in downtown San Diego. As you can see from these photographs, the site currently holds a vacant 4-story parking garage, which has 1 floor of commercial use. We will be demoing this building and replacing it with a high-rise that will consist of commercial, hotel, and residential space.
Hi, my name is Ethan Donnelly, and I am the geotechnical engineer at CDC.
The scope of work required for the geotechnical investigation report includes reviewing the existing conditions of the site, research of public geologic maps, aerial photos, topographic and fault maps was conducted in order to achieve a strong understanding of the existing site. An evaluation of the subsurface allows for a better understanding of the field conditions and is required to make accurate and informed recommendations to both the structural engineer and the general contractor. After reviewing the geologic maps of the area, it was determined that no faults run through the site. However, the site is in a seismically active area, as is typical for most of Southern California. Once the CPT data was collected, a simple graphical analysis was conducted. The graphs here show the soil strength versus depth, amongst other things, and can be used to determine the various soil layers on the site. The graphic here was used to determine the soil layers listed. I'd like to draw your attention to layer 5, where the bedrock was encountered at a depth of only 40 feet. This proved to be both a major challenge and a necessity for the success of the project. As seen from the CPT analysis, groundwater was encountered early on. Because of this, dewatering of the site is recommended during excavation. Implementing dewatering along with diversion of stormwater will greatly reduce erosion during construction, and these BMPs are highly recommended. The challenge faced with bedrock was that in order to meet the parking requirements, the ground parking garage needed to be extended 60 feet below the surface, thus requiring 20 feet of bedrock to be blasted and removed. By doing so, the quality of the bedrock increased from highly weathered to unweathered. This provided a sound natural foundation for the high-rise to sit on, and only simple, shallow foundations needed to be used.
My name is Ian Anderson. I am the site civil engineer and AutoCAD lead.
For the scope of our project, I created public improvement plans for our site. Street sections for both 5th Avenue and A Street were created for easier visualization and perspective. The section view of 5th Avenue is as if you are looking south, and A Street is as if you are looking east. The callouts for these sections are noted in the plan view. Next, I have created a plan view of 5th Avenue. The first thing you'll notice is that a new 4-inch sewer lateral is being installed. This is because the current building at this location doesn't actually have its own utility lines. They are shared with the building adjacent to the south. I have called out the trenching at about 2 feet on each side at the location of the new lateral. Additionally, as dictated by the city, an 82-inch offset area around the trenching is to be resurfaced. The street will be an AC overlay, and a new section of concrete will be constructed to match existing sidewalk. The only other public improvement on this street will be the construction of a new concrete driveway to accommodate a loading dock. Due to the newness of the sidewalk, it was decided that no other improvements would need to be made. For perspective, we have created a profile view of the street center line, as well as a top of curb with a proposed driveway as noted here. A Street had a few more utility improvements than 5th Avenue, but no new sidewalk needed to be constructed, besides the area where the utility laterals are being installed. The utilities being installed on this street are 2 20-inch fire water pipes and a 2.5-inch potable water pipe. Again, the trenching extends 2 feet out from the location of the laterals, and an additional 82-inch offset of resurfacing, both AC and concrete, is required. We have also included an existing profile of A Street centerline and top of curb for reference. Next, I created a site plan for our project. There was no grading needed because the site, in essence, is a hole in the ground. But slopes were needed to be calculated, steps measured, and ADA ramps designed in the patio area. First, a basic demo plan was produced. As called out, most of the street objects, such as trees and signs, needed to be removed. After that, the entire existing building would be demolished. The demolition area is marked in cross-hatching. For the grading plans, the biggest issue I faced was designing the stairs and ADA ramp. There's about a 12-foot change in elevation from the northeast corner to the southwest corner. In order to accommodate for this change, I designed 14 steps with a 0-inch riser on the east side, gradually raising to a 6-inch on the west. The ADA ramp was the most difficult design of the project because of the restraints and regulations. The ramp could not exceed an 8% slope in the direction of travel, and there needed to be a level rest area every 20 feet with 6-foot clearance in all directions. This caused the ADA ramp to be longer and wind more than I would have liked, as well as take up more of the patio than was expected.
Hi, my name is Alfonso Colmenero, and I am the structural engineer for CDC. The purpose of the structural analysis is to provide design recommendations for the 40-story high-rise. This analysis was accomplished by first obtaining the relevant building codes and gathering site layout information. This was necessary as the constraints for the building shell were needed to be determined prior to the start of the analysis. The design of the building shell was accomplished with LRFD in mind. The methodology considered was top-down. The structure is composed of reinforced concrete whereby column dimensions and PT slabs were designed for each story. Naturally, as the building approaches the lobby and below, the dimensions for the columns would increase to accommodate for the weights produced by the higher stories. This analysis continued further down to the parking structure until the foundation was reached. It was determined that 2 structures would be required. The main structure would be composed of 40 stories, whereby it would be 100 feet in length, 90 feet in width, and 492 feet in height. Each story would be 12 feet in height, and whilst the lobby would be 24 feet. The second smaller structure is only composed of 4 levels, and its dimensions are 60 feet in length, 50 feet in width, and 60 feet in height. This smaller structure would accommodate the pool, utilities, loading, spa fitness, and the hotel bar lounge. Once the analysis and design of the building shell was completed, the engineering documents were then produced to help provide a cost estimate for the building.
Hi, my name is Nabil Abdu, and I'm the water engineer for CDC. A green roof will be implemented on the 40th floor to help reduce the runoff condition by 40%. The green roof will be made up of 2 soil layers. The top layer will be a sandy silt, and the bottom layer will be a clay. The water that will be captured will be reused for landscaping purposes throughout the building. The rest of the runoff will go through a path of landscape on its way to 5th Avenue, where it will be collected by the inlets there. Due to the current condition of no utility laterals going to the current building, CDC had to conduct calculations to figure out the appropriate sizes of the new laterals that will be going into the high-rise. Our calculations have shown that the appropriate potable water lateral size will be 2.5 inches in diameter. And for fire, there will be 2 separate laterals at 20 inches in diameter each. And finally, for sewer, it will be 4 inches in diameter.
Hello, my name is Nick Messler, and I am the Traffic Operations Engineer for Civil Development Company.
Here at the 1245 5th Avenue redevelopment project, the proposed site has an estimated trip generation of 160 vehicles at the PM peak hour. And as you can see on 5th Avenue, traffic is light. Additionally, on A Street. Thus, we expect that the 160 additional vehicles to the network will not greatly impact the existing infrastructure. Additionally, all vehicles will be entering through a garage elevator on 5th and exiting on A Street. Therefore, no vehicles will be moving through the intersection behind me at 5th and A, and the vehicles will only be split at the incoming intersection at 5th and B Street and at the outgoing intersection at 6th and A.